Alrighty, so we're trying to get the sine by itself, which is our strategy we're going to use anytime there's just one trig function. So we multiplied both sides by 3. And then we're going to subtract the 1. That's not right. There we go. Negative 4.9. And then I'm going to divide by 2. We look at our chart. That's not our chart. So whenever we go to the calculator, we go trig, we go sine, and I'm doing negative 2.45. Calculator gives me an error. It says it's a non-real calculation. What's the problem? What's wrong, calculator? What's your problem? Why don't you like this? Why doesn't the calculator like this? Think about your graphs for sine and cosine. What is the range for your parent function for sine? Sine started at 0, 0. Sine would go like this. What was that maximum value right there? That was a 1. What was my minimum value right there? Negative 1. So for sine, all right, its range was between negative 1 and positive 1, which means for inverse sine, its domain was between negative 1 and 1. So my values of x has to be between negative 1 and 1. This is too big. I'm not going to have this y value. When I look here, when I'm solving, I'm looking for the x. I'm looking for what x value gives me this y value. My y values max out at 1 and negative 1. So this would be a no solution. Okay? How did I know it's no solution? 2 ways. Number 1, this is out of the range. Number 2, I typed it in the calculator and it said no good. It said non-real calculation or whatever. I'm going to run into this with sine and cosine. I'm also going to run into this with secant and cosecant because they are reciprocal functions. With secant and cosecant, those, alright, so here's a real quick sketch of secant. Secant had 1 and negative 1 there. It didn't use values between 1 and negative 1. So if you're asked to find, you know, where is the secant positive 1/2, that's not going to exist. It doesn't use anything between positive 1 and negative 1. So those are things to look out for. But we typed it in the calculator and we saw an error. We saw no solution. First we looked on the chart, nothing here. Went to the calculator, nothing there either. No solution. Alright, next. Eight cosine squared x minus 3 equals 1. Alright, so how many trig functions? Just 1. So same strategy from the one a minute ago. I'm just going to get the isolate the trig function, isolate the cosine. So I'm going to add a 3 to both sides. 8 cosine squared equals 4. I'll divide by 8. Cosine squared x equals 1/2. Then I'm going to take a square root. So what's going to happen when I take a square root? Plus and minus. Square root of 1 is 1 over the square root of 2. Well, what happens when I rationalize that? I get square root of 2 over 2. Plus and minus square root of 2 over 2. So when I look at my chart, alright, cosine square root of 2 over 2, alright, that's at pi over 4. So that's my reference angle. So that's half of what I need. Then I got to talk about quadrants. So if we have positive and negative square root of 2 over 2, then which quadrants are we working in? We're working in all four quadrants, the positives and the negatives. So x equals pi over 4, there's quadrant 1, quadrant 2, 3 pi over 4, quadrant 3, 5 pi over 4, and quadrant 4, 7 pi over 4. So this particular problem had 4 answers. A minute ago we had no answers. Just depends on the situation. Next 6 weeks when we do stuff, we'll have some that have 8 answers. Alright, let's look at this one. 2 sine x cosine x equals negative cosine x. So I've got more than one trig function. So it's not like the other ones where I'm just going to isolate the trig function because there's more than one. I wish that camera would get focused. Quit jumping around. So what should I do? What should I do? What should I do? What should I do? Who thinks we should divide both sides by cosine? If you think we should divide both sides by cosine, you are wrong. Dividing both sides by cosine loses an answer. It loses a root. You did stuff similar to this in Algebra 2. I want to solve this. I'm not going to divide both sides by x because I'm going to lose a root. That was the terminology you used. What did you do? You got it equal to 0, and then you factored. Then you set each factor equal to 0. This was how you solved this kind of stuff in Algebra 2. That is how we're going to solve this kind of stuff in pre-cal. So we're going to take that negative cosine x, we're going to add it to the other side, so I'll have a 0 over here. So I'll have 2 sine x cosine x plus cosine x. We're going to factor out a cosine. So in this term, I have 2 sine x. Over here I factored out a cosine, so what's left over there? A 1. Don't say 0, don't say nothing, it's a 1. Equals 0. Can I leave off this equals 0? No, I cannot. That's wrong. That's an invalid step. You've got to have the minus 0. After you factor, what do? Well, you set both factors equal to 0. So I'm going to have cosine x equals 0. I'll have 2 sine x plus 1 equals 0. Over here, the trig function is already isolated, so I'm not going to do anything with this except actually get our answers, which we'll do that in just a second. Let's go ahead and solve this. So I just need to get the sign by itself. I'm going to subtract the 1. I'm going to divide by 2. Sine x equals negative 1/2. So now I've got these two little equations to solve. Now how am I going to solve them? The same way I solve this stuff here on the first page. If it's on the chart, then I'm going to have exact answers. If it's not on the chart, then we're going to go to the calculator and get the reference angle. Alright, so cosine is 0. Where is the cosine 0? This is an axis question. When I look here at cosine, it says cosine is 0 at pi over 2. So I just got to ask myself, is it just pi over 2 or is it pi over 2 and 3 pi over 2? Pi over 2 and 3 pi over 2 both have a 0 for the x-coordinate, so cosine is 0 in both of those locations. So this will have a pi over 2 and a 3 pi over 2. What about sine x equals negative 1/2? Well, same kind of stuff. Get a reference angle. Sine is negative in quadrants 3 and 4. Sine is 1/2 at pi over 6. So pi over 6 in the third quadrant would be 7 pi over 6. In the fourth quadrant, that would be 11 pi over 6. And so those are all our answers here. So when I take these answers and plug them in, they work. That's the way it's supposed to work with an equation. You know, that's when you first started algebra, that's what you did. You took your answers and you plugged them in, you checked your answers. So if I take a pi over 2 and plug it in all these places where I have an x, one side should equal the other side. So you can always check your work. And sometimes we're going to need to check our work. Here I got a cotangent. I have a cotangent squared, and then I got a regular old cotangent, and I got a plus 4. So 3 cotangent squared equals 4, cotangent plus 4. Got a cotangent squared. Ooh, well, cotangent squared. Well, I could use my Pythagorean. No. I don't want to get more trig functions in there. These are all the same. They're all cotangent. I like them being all the same. But one is squared and one is not. So what am I going to do? I'm going to take this stuff. I'm going to move it over here to this side. And I'm going to factor it. Something squared, something, and a constant. So 3 times 4 is 12. I'm looking for factors of 12. Let's subtract to give me 4. 3, and then instead of a 3x like we normally have when we factor, it's going to be 3 cotangent. Remember, it's whatever's here. We factored like this with ease in our exponential chapter, the log and exponential chapter. We had e squared and an e, e to the 2x and an e to the x. So whatever you have here, that's your singular term that's going to go here. So 3 cotangent and just a cotangent. Got to put your equal 0. So factors of 12, let's subtract to get 4, that'd be 6 and 2. So I need a 2 here to make my 6. And then there's my 2. I need a negative. So that's negative and that's positive. Double check your factoring. That's a 3 cotangent squared, a negative 6 and a positive 2. That gives me a negative 4. Negative 4 right there. We're all good. And then I'm just going to solve. Set each factor equal to 0. So set that factor equal to 0, 3 cotangent x equals negative 2, cotangent x equals negative 2/3. So we'll solve that one in a minute, either using the chart or the calculator. Cotangent x minus 2 equals 0, so cotangent x equals 2. So we're ready to solve these. So we're looking at our chart. Let's see, do we have a 2/3 or a 2? Well, looking at cotangent, I just got square roots of 3's and 1. Another kind of a square root of 3, square root of 3 over 3. I got a 0. No, none of that there. So both of these are going to be answers from the calculator. So this one has a negative cotangent. So that one is going to be using quadrants 2 and 4. So we're going to go to the calculator. Alright, I'm going to go inverse tangent, and I don't type the negative. Whoops, not tangent, cotangent. Try again. Try again. Inverse cotangent. Don't type the negative because I'm getting a reference angle. 2/3. I got 0.983. Alright, so I'm just going to write down that number, 0.983. That's my reference angle. So I'm just writing down that much. Remember, I'm going to use everything. So for quadrant 2, we're going to say pi minus, go up and grab the whole thing, 2.159. 2.159. For quadrant 4, how do I find the angle in quadrant 4? Remember, we're always subtracting from the x-axis. What's on the x-axis? Well, 0 is, but also 2 pi, and that's where we are in the 4th quadrant. We're getting close to 2 pi. Oh, I didn't put my minus sign. Minus 5.300. 5.300. Do you have to put the 00? Yes, you do for me, because I told you to round to the thousandths. And if you don't put them, I think you're just read the directions wrong and thought I said tenths. So put both of those. All right, now I need our answers for cotangent theta equals positive 2. So positive, we'll use answers from quadrants 1 and 3. So I need a reference angle for that. Cotangent. positive 2. So this is my reference angle, which is also my first quadrant answer. So 0.464. And then for quadrant 3, we say pi plus that number, 3.605. And we will not be using degrees. We're going to solely use radians in all of this. So all of your answers should be less than 2 pi. How much is 2 pi? 6.28 approximately. You know, double your pi, double 3.14. So that was just a regular old factoring question, disguised as a trig question. Let's look at 9. Sine x equals a negative square root of 3 times a cosine. All right, well, if I try what I've done before and say, let's just move this cosine over, I would have a sine x plus stuff with cosine. All right, that's not very helpful. What about using a trig identity? Could I use a Pythagorean identity and maybe substitute something in there for sine or cosine to get sine or cosine? Well, no, because this is sine squared and cosine squared. Those are not squared. What about using reciprocals? All right, well, I could turn a sine into a 1 over cosecant and a cosine into a 1 over secant. That still doesn't help me. That still gives me 2 trig functions. This is what we're going to do. I'm going to divide both sides by cosine. That's what I'm going to do. Because sine over cosine is tangent. And now I have this to solve. Now, here's example 7. When we did this, I said, do not divide both sides by cosine because you would lose a root. If I divide both sides by cosine, it cancels on the right and it cancels on the left. When I divided by cosine here, it canceled on the right. But it did not cancel on the left, it transformed on the left. That is legal. The cosine didn't go away. The cosine is just rewritten now, combined with the sine to make a tangent. So it's legal here, not legal here. If it cancels on both sides, that's a bad thing. You're losing a root. I did not lose my cosine. It just changed. Okay? Everybody see the difference? Hopefully you see the difference. Why it's okay here, but it wasn't okay over there. All right, my tangent is negative. So my answers are going to be in quadrant 2 and quadrant 4. Tangent, square root of 3 is here. So that's pi over 3. So in quadrant 2, that'd be 2 pi over 3 and 5 pi over 3 for quadrant 4. So there we go. That's that one, that strategy. Dividing both sides by cosine, I created a tangent. The cosine did not cancel on both sides. It transformed over here. That's not a cancel. That's a rewrite. That's a transform. Okay? Oh my gosh, why are those super small? All right, I'm going to rewrite these. That's super, super tiny. Let's see here. Example 11. All right, we'll do that one next. Sorry. You gotta wait on me. 2 sine x, negative 2 sine x cotangent x. Here we go. Here's example 10. So, what's my strategy? What's the strategy? What are we going to do? What is this one similar to that we've seen before? Do I want to divide both sides by sine? Good idea, bad idea. What do we think? Oh, just say no. Don't do it. So we're going to factor. We're going to move it over. We'll get it equal to 0. So we're going to add, we'll go and add this over here. 2 sine x plus 2 sine x cotangent x equals 0. What can I factor out of that? I can factor out a sine. I can also factor out a 2. I can factor out a 2 sine. Factoring out the 2 is not critical. I don't have to factor out the 2. I will, but just know you don't have to. Your answers will still come out the same even if you leave the 2 in there. So when I factor out a 2 sine, well, now this term is going to be a 1, and this term is going to be a cotangent. All right, set each factor equal to 0. So when I divide both sides by 2, all right, 0 divided by 2, still 0. So that's, the 2 is not going to matter. All right, I move this over. Cotangent x equals -1. So where is the sign 0? That's 0 in pi. Where is cotangent -1? Cotangent is negative in quadrants 2 and 4. This is a reference angle of pi over 4, 3 pi over 4, and 7 pi over 4. Now, before we box this in, we need to see if there's any problems with this. I need to check for problems in equations, let's say that word. When I have equations that are using one of my 4 trig functions that have asymptotes in the graph, that have places where they are undefined. Let's look through the examples we've done so far. All right, this had a cotangent, but I was just solving. That was just very, very simple. This had a secant, but that was the only trig function in the problem. If that's the only one that's in the problem, you're not going to, everything's going to be okay. Cosine, this had sine and cosine. Those are defined everywhere. Here I had a cotangent, but that's all I had. If you have the same trig function all throughout the problem, then everything's going to be okay. You don't need to be worried. This ended up only having a tangent. Everything's okay. Here, I have a cotangent, which is undefined in places, and I have another trig function with it. So this makes me worried. If I take my answers and plug them in, they're supposed to work. If I plug in a 7 pi over 4, everywhere there's an x, it's supposed to work. Let's try it. Where's my stuff? Here we go. So if I plug it into the left side, I'm going to do the 3 pi over 4. 3 pi over 4. So plug it into the left side, that's the decimal that I get. Plug it into the right side. So it was -2 sine 3 pi over 4 times, whoops, get out of the parentheses, there we go, times cotangent, parentheses, 3 pi over 4. So this was the left side of the equation. This was the right side of the equation, so they should equal the same number, and they do, which that happens to be square root of 2. What happens if I plug in a 0? What's the sign of 0? 0. What's the sign of 0? 0. So you were thinking, all right, that whole side is 0 because 0 times anything is 0, right? Wrong. What happens if I plug in a 0 into cotangent? What happens when I plug in a 0 into cotangent? What happens when I plug in a 0 into cotangent? Oh my gosh, it's undefined. So that means that this 0 and pi right here, not good answers. Because when I plug them in, they don't work because I get undefined in places. So I'm only going to have 2 answers on this one. So these, you've heard this phrase before. I got extraneous solutions. We did some problems early in the year that had extraneous solutions. You did a lot of them, maybe not a lot, but you did them last year in Algebra 2, where you got to go back and check. So I'm telling you when to be worried, when to check. When I have an asymptote function, so one of my 4 functions that has asymptotes, and another function of any kind. It could be another one that has asymptotes, but it has to be a different function. Okay? All I got to do is when I get to the end, look and see, are any of these the asymptotes? 0 and pi. That's where cotangent has asymptotes. This is another reason why we graphed. We graphed so that you hopefully got the parent function tables ingrained in your head so that you knew for sure, especially for these 4 where they have asymptotes. Your cotangent parent function table started at 0, ended at pi, went from asymptote to asymptote. You've got to know where these asymptotes are. You got to know this quick. Oh, 0 and pi, I'm using cotangent, no good. All right? So, you got to watch out for extraneous solutions. All right, number 11. 2 cotangent squared equals -3 cosecant x. So I have 2 different trig functions. On some of these other problems, my first step was to get it equal to 0 and factor. Alright, I got it equal to 0, but there's nothing here I can factor out of this. You can factor in x. No, you can't. That's the angle. You can't touch that. You have to leave it where it is. I can't have a cotangent squared and nothing over here. I can't have a cosecant and nothing here. That's the angle. Don't mess with the angle. I cannot factor out an x. So I'm looking at this. I'm like, it'd be nice if something was the same here and here so I could factor it out. That would be nice. Sure would be nice. That would be nice. Let's make it happen. Cotangent. Cotangent can be rewritten as cosecant squared minus 1. So, cotangent squared, which is being doubled, can be written as cosecant squared x minus 1. Got to put in parentheses. I'm going to have to distribute. Don't forget to keep writing your equals 0. 2 cosecant squared x minus 2 plus 3 cosecant x equals 0. So we distributed. Now what? I've still got a minus 2. I can't necessarily just factor out a cosecant. But what's the pattern here? I have one that's squared. I have one that is not squared. And then I have a constant. This is 3-term factoring. If I give you a problem that has 3 terms, like this, if it doesn't factor, your other options would be using quadratic formula with this. That's really ugly. We're not doing that. If it looks like this, it's going to be able to factor. If you're trying to factor and it won't factor, then you made a mistake somewhere up here. Go back, find your mistake, because these are going to be able to factor. Okay? 2 cosecant x. No, not 2 over here, just cosecant x over here. Factors of 4 that subtract to get 3, so that would be 4 and 1. Positive 4, negative 1, because the 3 is positive. So 2, 4, 1, yeah, checking all answer, equals 0. Don't forget to write equals 0. Alright, so setting this one equal to 0, cosecant x is 1/2. Setting this one equal to 0, moving that 2 over, I get a -2. Let's see if these are on the chart. Cosecant. Cosecant, looking at my chart, 2 is on my chart. 2 has a reference angle of pi over 6. So x equals, alright, so cosecant is negative. Let's see, cosecant is the reciprocal of sine, so that would put it in quadrants 3 and 4. What we said the reference angle was pi over 3. So 4 pi over 3 and 5 pi over 3. What about 1/2? Look at cosecant. Sine and cosine have a 1/2. All right, but we're not looking at sine and cosine. We're looking at cosecant. It'd be nice if you could see it on the screen. We're looking at cosecant. Cosecant does not have a 1/2. So what do? I'm going to go to the calculator. Or, because I'm just really smart like that, I'm going to remember that cosecant, the graph of cosecant has a gap in it. You can't see that point. I typed 0.5. Can't really see my point. Lots of you can't always see my point. Haha. Okay, here we go. Cosine 1/2. Oh, duh. Type inverse cosecant. Sorry. Inverse cosecant. 1/2. And what happens? Non-real calculation. My graphs for secant and cosecant had a gap. They didn't start. Those graphs didn't start until 1 and -1. Those graphs started at 1. Started over here at -1. There was nothing in between. 1/2 is falling in that dead space, that in-between space. So this just doesn't work. Think of it like whenever you were solving some things and you would have x squared here and you'd have a negative number here. Well, when I take a square root, I'm going to get imaginary, no good. Same kind of situation, no good. I didn't get any answers from this. I did get answers from this part, and so this one only has 2 answers. All right, last one. Oh, wait. Go back. Extraneous solutions. Are these extraneous solutions? We started off with cotangent and cosecant. Where do cotangent and cosecant have asymptotes? Because those are the things I would have to throw out. Cotangent and cosecant had asymptotes in the same places. Asymptotes at 0 and pi. Did I say 0 or pi were answers? No, I did not, so these are good. I only have to throw out the stuff that's asymptotes for what I had at the beginning. Now back to this. Last example. 3 tangent to the 4th equals 5 minus secant squared. Alrighty, well, first thing I pretty much always want to do is get it all equal to 0. That's usually my first step. Even on these first ones, I'm isolating. I had one trig function, so I'm isolating that one trig function. On these others, one trig function isolate. This, get it equal to 0. You can't even see that. Get it equal to 0 and factor. So if it's not one trig function, generally you're going to be getting it equal to 0 and trying to factor it. 3 tangent to the 4th minus 5, plus secant squared equals 0. So that's where we are. I've got tangents and secants. I would really like it if I just had one or the other, because I've also got this constant in here. I can't factor stuff out. So my identity, 1 plus tangent squared x equals secant squared x. This is my identity. I actually have 2 choices here. I can take this tangent, alright, and rewrite it as 3 tangent squared, and then solve this for tangent squared and plug in here secant squared x minus 1 and then square that out. I like math, I like trig, I really like identities, but I don't think that would be very fun. Taking this secant squared and plugging in 1 plus tangent sounds like a really good deal, especially since there's just a plus in front of it. I don't even have to distribute anything. If this was a minus, I would have to have it in parentheses. I would have to distribute a negative. Okay? So this looks like my best option. Minus 5 plus 1 plus tangent squared equals 0. So this right here, my secant squared, got replaced with a 1 plus tangent because of my identity up there. I'm going to combine my like terms. All right, 3 tangent to the 4th x plus tangent squared x minus 4 equals 0. This is 3-term factoring. I have something in the middle, and that something is squared over here, and a constant over here. That's the form. Something here, squared over here, constant over here. 3 times 4 is 12. I'm looking for factors of 12 that subtract to give me 1. And what am I going to write here? It's always whatever this term is. So not 3x, not 3 tangent x, but 3 tangent squared x. And then a 1 tangent squared x equals 0. Look, I wrote my equals 0. You can't see it all the time, but it's there. What are we doing? Factors of 12 that subtract to get 1. So I'm going to need a 3 and a 4. It's a positive, so that's positive, that's negative. Check it out. 3, negative 3 and positive 4, negative 4, that's all good. Alright, set each factor equal to 0. So over here, I'm going to run out of room. I'm going to need to write on another sheet of paper, it looks like. Alright, so over here, three tangent squared equals negative 4. Tangent squared x is a negative 4/3. What do you think about taking a square root of that? I think it's no good. I don't want to work with imaginaries. We're not working with imaginaries here. We are solving between, our answer should be between 0 and 2 pi, and imaginaries don't fit there. Over here, what am I going to get over here? Tangent squared x equals 1. Take a square root. Tangent x equals not just 1, but plus or minus 1. So when you get a plus or minus, you're going to get answers from all 4 quadrants. Look, I don't even need this sheet of paper. I thought I was going to need that paper. So plus or minus 1. Where's the tangent 1? Pi over 4, so that's my quadrant 1 answer. 3 pi over 4. 5 pi over 4. And 7 pi over 4. So there's my 4 answers there. So this side didn't work out. Let's say this did work out. Let's say this was positive. Well, I would get 4 answers from this one and 4 answers from this one. I would have 8 answers. This one was imaginary. Let's say this one ended up being imaginary also. Then I would have no solution. Nothing worked. Okay? That could happen too. You can have anywhere from no answers to 8 answers. It just depends on what's going on. Alright, so looking back at the beginning, that was just basic solving. When I'm going to my calculator, make sure you only type the positive. You're going to get your reference angle, and then you got to do what you're supposed to do to get your angle in the quadrant. So in quadrant 2, I'm going to be subtracting from pi. Quadrant 3, I'm going to be adding pi. Quadrant 4, I'm going to be subtracting from 2 pi. Only type the positive in the calculator to get the correct reference angle. Next page, we had single trig functions. We just isolated the trig function, went to the chart when we could go to the chart, used the calculator when we could use the calculator. This one was a no solution. Sine and cosine cannot have anything bigger or outside of the range -1 to 1. This also had one trig function. It was just squared, so we isolated it. When I take a square root, I need a plus or minus, so I'm getting all 4 quadrants as answers. Over here, we had this. We were not going to divide both sides by cosine. That is losing a root. So we moved it over and we factored. What did we do here? This was a 3-term factoring. Something, that something squared, and a constant. And these answers we ended up getting out of the calculator, having to add pi, subtract pi to get all those values. Over here we divided by cosine, and it was okay because it didn't cancel on both sides. It got transformed on that side using our chart to get those answers. Here's another one where we got it equal to 0, and factored, set each factor equal to 0, but I had to go back and make sure that the answers were okay, because 0 and pi don't work with cotangent. Cotangent had asymptotes at 0 and pi, so those answers were no good, so we only ended up with 2. We had extraneous solutions. When do I need to worry about it? When I have an asymptote function and a different other function in the problem. Here was one where we used a Pythagorean identity, so that it was all cosecants, and then we could do 3-term factoring. And then the last one is a similar situation where I used a Pythagorean identity and then did 3-term factoring, but it ended up being something to the 4th and something squared instead of just a squared and a single. So that's what we did. So what are we doing here? This was today, solving trig equations. This worksheet is due next time on Thursday. You will get your review. You will take a quiz over this section. And Mr. Fort's going to grade those quizzes. I'm saying it right now, and you better listen. And Mr. Fort, don't be nice. If they don't put this equal 0, you count off. Count off at least 2 points. Maybe even 4. I don't know. Count the whole thing wrong for all I care. I'm telling y'all, put your equal 0. We've talked about this all year. Some of you, first 6 weeks, I was telling you to put equal zeros. You've got to have every step correct. Okay? It's not, we're not going to do that anymore. So, review on Thursday, quiz. You can stop by sometime on Friday, see if Mr. Fort has them graded so you can study them over the weekend. Chapter test on Monday, 6 weeks review on Wednesday, 6 weeks test on Friday. Blank reviews and keys are posted on the website so you can get to those. And then you'll have new lessons starting with the new 6 weeks. On your tests, be prepared to fill out a blank chart. Maybe I'll give you a real chart, maybe I won't. But you need to be prepared every time to fill out a blank chart. There's blank charts on the website. There's blank charts on my desk. They should still be in the same place. To the left of where the folders for the keys are, kind of standing up by that stack of books. So get some blank charts, practice, print them off the website, whatever you need to do. This trig chart that I gave you, you know, it's great, it's handy, it's for study purposes only. I'm never going to let you use this on a test. Never going to let you use this on a test. I promise you, never let you use this on a test. So make sure that you know all those identities, that you're familiar with them in all different forms. So you can be ready for this test. The next unit, the next 6 weeks, is doing more of this stuff, just with all the rest of the identities that we have on the back. So you know some of them. These are the ones that we're going to be adding next 6 weeks. I said adding. So you still got to know all these other ones. We're still going to be using Pythagorean in conjunction with all these other new ones. So you got to make sure that you're familiar with this stuff before we start adding to it next 6 weeks.